It can be many miles long, from 1 to 100 feet high, traveling at 400 miles per hour. This ocean monster is known as a tsunami. A tsunami is a series of ocean waves caused by large, sudden movement in the ocean sea level. Tsunamis can be generated by earthquakes, landslides, and volcanic eruptions. It's known to destroy many cities in just minutes. Over the years, it's killed millions of people. When it hits, it comes ashore like a fast rising flood. The waves continue for hours. For your own safety, know the potential warning signs of a tsunami. Tsunami in the Japanese language means harbor wave. In the 1850s alone, tsunamis have been responsible for the loss of millions of lives and billions of dollars of damage to coastal structure and habitats. Because Japan has historically suffered the most tsunamis, it's only natural that Japan would be the first country to develop tsunami warning systems. Japan's development of tsunami science began in 1896 when a giant earthquake hit Sanriku, causing a chain reaction which started a tsunami with heights of up to 38 meters. Around 1910, Japanese researchers assumed that fault motions of earthquakes triggered tsunamis. In 1933, the Sanriku area was impacted by another giant tsunami. Because the earthquake produced violent shaking, many coastal residents evacuate to high ground, reducing the death toll to about 3,000. With the success of the first early warning system, if the ground shakes violently, evacuate. The Japanese Earthquake Research Group proposed an earthquake-centric tsunami warning system. Japan's first instrumental warning system was established in September 1941 in Sendai, Japan, and was designed to quickly detect the earthquakes. The first U.S. Tsunami Warning Center was then established in 1949 at the Honolulu Seismic Observatory following the death and destruction inflicted by the deadly tsunami in Hawaii on April 1, 1946. The U.S. adopted Japan's earthquake-centric approach and added a time of arrival capability for the world's first distant tsunami warning system. Japan led the world in developing an ultra-exclusive seismic network that can detect and determine the size of an earthquake in 3 minutes. Japan's system delivered 2 products: tsunami advisories and tsunami warnings. Tsunami warning were divided into 2 categories. Number 1, tsunami warning, where waves up to 2 meters were expected in some locations. And number 2, a major tsunami warning, where there were waves in excess of 3 meters predicted. By 1995, the level of warning was issued within 15 minutes of earthquake origin time for the near source tsunamis, and within 5 minutes of local tsunamis. NOAA, which is our National Oceanic Atmosphere Administration, designed a tsunami detection system in 1996. The current system is called DART-DUI. DART stands for Deep Ocean Assessment and Reporting of Tsunamis. Each DART station consists of 2 parts: a bottom pressure recorder, known as the BPR, and the service buoy. The BPR is located in the deep ocean. It measures changes in the amount of water above the pressure sensor. The BPR was programmed to ignore regular surface waves that would normally occur, but to detect bigger and more unusual rough waves. Once these rougher wave signals are detected on the seabed, a solar modem is used to transmit data from the BPR to the surface buoy. The BPR is powered by a large pack of D batteries, just like the ones you can buy in any general store. The surface buoy's number one job is to receive this data from the BPR using the solar modem and then relay information to satellites floating nearby. This signal has to then be transported to a nearby tsunami warning center. At the Tsunami Warning Center, there is a staff of researchers who would then evaluate the degree of any earthquake signals received. If this threat is significant enough, the public will then be notified immediately. There are several ways in which the public can be alerted, but the most common of these are cell phones, radios, and TV. The BPR collects data on the temperature and pressure every 15 seconds and then sends this information to the surface buoy. This is completely based on the mode in which the BPR is operating in. If the buoy is in standby mode, these signals will be sent to the buoy every 6 hours, and this is done to save on battery power. This is because the standard DART surface buoy has a design life of 1 year, and the seabed BPR package has a design life of 2 years. However, if pressure sensors within the BPR can sense an event that is above the normal temperature and pressure readings, then data will be sent back to the tsunami warning centers every 3 minutes until the situation returns back to normal conditions. The DART buoy technology was first developed at the Pacific Marine Environmental Laboratory, also known as PMEL, with the first prototype developed off the coast in Oregon in 1995. In 2004, the DART stations were transitioned from research at the PMEL to operational service at the National Data Buoy Center, also known as NBDC, who is also a part of NOAA. Ironically, that same year, we detected the second biggest earthquake in the Indian Ocean at a magnitude of 9.1. The only other earthquake bigger than this took place in Alaska on March 28 in 1964 at a magnitude of 9.2. In 2004, plans were made to deploy an additional 32 DART buoys around the world. By 2008, there were a total of 39 stations covering the Pacific Ocean, Atlantic Ocean, and the Caribbean Sea. Taking interest of their safety, more DART buoys were deployed through Australia, Chile, Indonesia, and Thailand by 2009.